So welcome you all guys to debugging doubts. Today let us understand more about the safety algorithm, which is also called as banker's algorithm. Okay. So before we learn about that, we'll see what is process queue and resource and all that stuff. So if you know all this stuff, then you can directly skip to the next part of the video where I have explained visually about the safety algorithm and banker's algorithm. So let us go step by step. So first thing is process. So what is process? Process is any program in execution. So process see this P0, P1, P2, P3. So there are five processes. So now let us consider that an example. Okay. So P0 may do some addition of three numbers something, and P1 process may do some multiplication of two numbers something. Okay. So each process does its own work. So in order to execute P Not's work, the maximum resource it required is 10. Means resource is so here in the case we can consider the CPU storage. Okay, take an example like P Not requires 10 MB of memory from the CPU. So now the currently P Not has already got the four resources out of 10. So what is the remaining? So 10 minus 4 is 6. So 6 is the need. So whenever it gets the remaining six resource, P naught will be completely executed and used resource will be sent back to the available resources. So now currently the available resource is six. So what I do is first thing we'll give some allocation, right? So we have six resources. So we'll put these six in the P naught one. So I'll allocate one, two, three, four, five, and finally when I add one more resource, so the resource is returned back. See, so it got all the 10 resource. So it completed execution and finally returned the memory back to the available resource. So now available resource is 10. Now what I do, I will put it to P1 only. See, when I give the remaining three resource and it got executed and finally it returned everything. Now we can also give for this one, P4. See, it executed and returned. And finally P2. So in this way, what we have done is we have executed the process in correct order and there was no deadlock. Means there was no such process which was starving out of memory or some resources. Now let us consider one more example. Now what I do is instead of giving this six available resource for P naught, I will give it to P4. Okay, so I'll give all the six resource. Okay, uh, 1, 2, 3, 4, 5, and 2 I will give here 6, and finally it is 0. Now what happened? We don't have any available resources, and we can't put it in any either of the process to get completed so that it may return the resource. So happens if I add in either of this process? So it says no available resource. So neither my process got executed and even I don't have any resources so that at least one process get executed. So each of the process is waiting for resources and finally we are in the deadlock state. In order to solve this problem, like in which order we should go so that all the process get executed, we have Banker's algorithm, which is also called safety algorithm. Okay, so let us see about that too. So this is Banker's algorithm. Now here you can see the safety algorithm. Right? This is Banker algorithm. So first thing, it has four steps. So first is work. So work is what? Work is available resource. Like currently, what available the resource are. So in the previous also we have seen, right? So same thing. Now you can see this maximum allocation and need. So what is maximum? Maximum means P naught requires this many number of resources. That is 7 from A resource A, 5 from resource B, and 3 from resource C. So whenever it gets all the resource, it will be executed. Now in the allocation, what we have written is, so out of this maximum, how many of the resources are given currently for P naught? That is mentioned in the allocation. And finally, the need. Need is the just difference. That is maximum minus allocation. So, and you can see this FF. So these are all false. Means process has not been executed. Once it is been executed, it will become true. And currently we have resource from A, and three resource from B, and two resource from C. Okay, and here you can see the code, that is system is ready. Now I will run the code. First I need to find the need matrix. So 7 minus 0, then 5 minus 1, 3 minus 0, 3 minus 2, 2 minus 0, 2 minus 0, 9 minus 3, 0 minus 0, 2 minus 2, 2 minus 2, 2 minus 1, 2 minus 1, 4 minus 0, 3 minus 0, 3 minus 2. And finally, we have found the need matrix. And you can see, now we start the safety algorithm. So safety algorithm got started. And now I start the next step. Okay. So in this step, what we do is, you can see work is equal to available, which I have already done. And finish of I is equal to false. So all the resources have been assigned false. Now we need to select an index I such that finish of I is equal to false and need of I is less than equal to work. What it means? So the process should not be executed. That is finish of I is equal to false and need of I is less than work. So need is this one, right? So this should be less than work. So whenever you are comparing need is less than work, you should not consider this is a three-digit number. You need to compare resource A with resource A only and resource C with resource C only. Okay. So let's compare. So 7 less than 3? No. So it will directly say rejected. So I'll start this. 7 less than 3? No. Fail because not enough to run process P naught. So P naught must wait. Now what I do, I'll go next process, that is P1. So I'll compare 1, then 2 less than 3, then 2 less than 2. Okay. So once I get like the need is less than work, then what I do? Work is equal to work plus allocation. That is what I done. So I added this 2 plus here it was 3, right? So it become 5, and 0 plus 3 is 3, and 0 plus 2 is 2. So this is how we calculated, and finally P1 is executed because it got all the resources and became true. Now I start the next process. So P2. So 6 less than 5 is already a false statement, so it got rejected. So I'll go for P3 now. So 0 less than 5, 1 less than 3, and 1 less than 2. So I'll add 2 plus this, and 1 plus this, and 1 plus this. And finally, I have added. So now work is getting incremented and process is being completed. So I'll go after P3, I'll go for P4 and I'll compare. So add this. Now P4 also got executed, and after reaching the end, what we should do? Wrapping. So once again, I go for P0. I'll check. Now you can see the available resource is fine. So I added the allocation. And next I'll go for P1, but P1 is already true, and we can see this finish is equal to false. Then only we need to execute. So we'll skip this one. So P2 also you'll find, and you can see. So you can add these two, and finally done. So you see all the process has been executed, and this is the final work available, and you can see the sequence. So when I click on next step, the system is in safe state because all the process got executed, and this is the sequence, that is P1, then P3, then P4, P0, P2. So this is how safety algorithm is used to check whether you can reach safe state or unsafe state. So what is unsafe state? Whenever either of the process cannot get available resource, so it will be waiting for a resource, and this is called a deadlock state. So neither the process get executed and neither you can provide memory. This was all for today, and if you like my videos, please like it, share it, and subscribe it. And if you like such animations in my teaching, so you can comment it below, and you can find the this website's link in my GitHub account, which is mentioned in the description. And thank you all, guys.